Imagine soaring high above the Florida Keys with nothing but calm skies and crystal clear visibility stretching for miles, when an unexpected explosion jolts the aircraft. A terrifying moment suspended in the skies. Panic fills the cockpit as the Airbus A310-300 begins to sway violently in a harrowing Dutch roll, a ghostly dance with fate that threatens to spiral out of control. But just as it seems all is lost, the seasoned flight crew wrestles control back from chaos, navigating the perilous depth of uncertainty. The passenger charter flight's desperate turning point unfolds, culminating in a discovery that defies belief upon landing. The aircraft's rudder had vanished. With only a minor injury reported among 271 occupants, how did an in-flight disaster lead to an undetected critical failure? On March 6, 2005, Air Transat Flight 961 lifted off from the sun-bathed runway of Varadero, Cuba, embarking on what was supposed to be a routine charter flight to Quebec City, Canada. With 271 passengers and crew settled in for the journey, the skies above were painted with the promise of a seamless flight, the kind the Airbus A310-300 was engineered to deliver. This 3-decade-old aircraft, part of a revered lineage of civil aviation, had been trusted for countless journeys. Little did anyone aboard anticipate the turbulence that lay ahead, not from weather, but from the skies themselves. Shortly after reaching cruising altitude at flight level 350, at a height of approximately 35,000 feet, an unexpected and deafening bang punctuated the tranquility. The sound reverberated through the cabin, unsettling even the most seasoned flyers among them. In the cockpit, trained to attune themselves to the aircraft's every nuance, the flight crew felt the disturbing onset of vibrations coursing through the fuselage, a sign that something wasn't right. The suddenness of the noise and the ensuing shudders sent ripples of anxiety through the cabin, an imperceptible signal translating into widening eyes and tightened grips on armrests. For those in command, Captain Robert Pichet, a veteran aviator with a storied reputation, highlighted by his famed glider-like landing of a fuel-starved Airbus in the Azores just 3 years prior, and First Officer Dirk de Jager, the situation demanded immediate assessment and swift action. They glanced across the illuminated dials and screens, seeking any indication of malfunction. No alarms blared, no gauges betrayed the cause of the noise, leaving the pilots in a critical juncture of uncertainty. Yet, training supplanted emotion, compelling them to maintain composure under mounting pressure. The passengers, largely unaware of the extent of unspoken tension developing in the cockpit, continued to search each other's expressions for reassurance. Flight attendants, while executing their duties, quietly navigated the aisles, their professionalism unbroken. In such moments, silence speaks volumes. Both the mundane and the extraordinary collided, pausing the predictable course of the flight, suspended between stability and chaos. The decision-making process accelerated. The crew, while attempting to understand the anomaly, adhered to protocol, initiating immediate communication with air traffic control. Their coordination with flight operations on the ground proved crucial in covering all operational bases, considering potential threats to the aircraft's integrity. Meanwhile, the aircraft continued on its path, each mile traveled transforming what was once ordinary into a burgeoning saga of survival. At the heart of every flight lies the defining ability to confront the unforeseen. The bang and vibrations were more than anomalies. They were premonitions of the unfolding drama that mere aerodynamic understanding couldn't fully explain. The expertise exhibited by Captain Pichet and First Officer de Jager in leveraging their experience and calmness became the aircraft's lifeline. At an altitude where the margin for error is virtually non-existent, every movement, every decision carried weight beyond the cabin's steel confines. As time ticked forward, the situation demanded more than observation. The reassurance of clear skies melded uneasily with the persistent uncertainty of the aft impending dance, the Dutch roll. This unusual lateral movement would soon forge its way into the narrative, challenging the pilots to their limits. Yet within this developing story, the rumble that disrupted the flight was merely the prologue to a much larger quest for resolution and safety. As Air Transat Flight 961 ventured further, navigating both the skies and the evolving mechanical dilemma, the integrity of the aircraft seemed to teeter on the cusp, demanding meticulous attention to calibration. The crew now faced the persistent haunting of the unexplained bang, ready to pivot into the heart of corrective action. As Air Transat Flight 961 continued its journey high above the Florida Keys, the initial shock of the loud bang transitioned into a more pronounced manifestation, a disorienting Dutch roll. This aerodynamic phenomenon, characterized by a combination of side-to-side yaw and rolling motions, presented a dire challenge to the seasoned crew at the helm. Such a dynamic imbalance is particularly daunting at cruising altitude, where corrective measures are limited and the consequences of any delays could be catastrophic. Inside the cockpit, Captain Robert Pichet and First Officer Dirk de Jager recognized the telltale oscillations, the plane's wingtips rising and falling in an uneven yet rhythmic motion that started sapping the stability of the aircraft. A Dutch roll at this altitude was not merely a mechanical peculiarity, it was a threat that demanded immediate skilled intervention. With each passing second, the margin for successful corrective action narrowed, necessitating razor-sharp focus and precise maneuvering to regain control over their aerial environment. Seated in the calm yet tense atmosphere of the flight's command center, Pichet and de Jager embarked on a series of methodical remedial maneuvers. Understanding the gravity of the situation, the pilots used manual controls, counteracting the aircraft's yaw and roll with calculated adjustments, an intricate ballet of inputs reliant on their aerodynamic acumen and intimate familiarity with the Airbus. The absence of immediate alarms or technical failures on the instruments only compounded the challenge, forcing reliance on intuition and experience rather than clear-cut diagnostic cues. Meanwhile, within the passenger cabin, the illusion of tranquility unraveled as keen observers noted the subtle yet disquieting changes in the aircraft's motion. Passengers exchanged apprehensive glances, while flight attendants, trained for such uncertainty, endeavored to sustain a veneer of calm, offering reassurance through their presence and professionalism. The collective unease hummed quietly, overshadowed by the physical sensation of the aircraft's lateral swing. The time-sensitive nature of their task spurred the pilots to trust their instincts and training, conducting swift yet controlled movements to stem the oscillations. Slowly but surely, their perseverance bore fruit. The erratic motion started to recede, the aircraft gradually aligning from its precarious listing. This stabilization was not just a testament to the pilot's skill, but also pivotal in reducing anxiety levels amongst passengers who began feeling a semblance of normalcy return. Despite this momentary reprieve, the gravity of the situation lingered like a specter in the cockpit. Even though immediate peril had been averted, uncertainty remained about the aircraft's underlying mechanical integrity. There was no room for complacency, as their pivotal intervention had only redirected the narrative of the flight, not closed it. Pichet and de Jager's actions bought time, but critical questions loomed about the plane's capacity to sustain safe flight and eventual landing. With the Dutch roll now subdued, the atmosphere on board softened slightly, yet remained thick with anticipation. The next critical phase was determining the most prudent course of action, whether to divert mid-route for checks or return to Varadero, balancing potential risks against the need for decisive safety evaluations. The story of this flight had many chapters yet to unfold. Foremost amongst them was the resolution of its complicated mechanical mystery, one that underscored the unyielding demands of air safety. With stability tentatively restored, the crew faced their next decision, imperative for ensuring the security of all on board. In the aftermath of the unsettling Dutch roll encountered by Air Transat Flight 961, it was clear that the stakes were monumental. As the aircraft steadied from its pendulum-like dance, the primary objective for Captain Robert Pichet and First Officer Dirk de Jager transitioned from combating immediate flight instability to ensuring a safe descent. With the immediate danger curtailed through their expert handling of manual controls, the pilots forged a path through uncertainty to mitigate potential risks as they brought the aircraft lower into denser, more navigable air. The experienced pilots, having already demonstrated exceptional control in the face of adversity, now focused their combined expertise on two fronts: validating the aircraft's operational integrity and and strategizing its subsequent trajectory. Captain Pichet, whose previous heroics were storied within aviation circles, drew upon every ounce of skill and instinct honed over countless hours in the cockpit. De Jager, a formidable co-pilot with crucial technical insight, duplicated this resolve, establishing a clear line of communication with air traffic control to negotiate an appropriate response to the exigency. Inside the fuselage, the palpable tension eased among passengers and crew as a natural gravity rooted them to their seats. Flight attendants, persistent in their mission to uphold safety and comfort, quietly assessed the situation, ready to pivot should new instructions arise. Passengers, while informed about the situation to avoid instigating panic, remained largely unaware of the intricate maneuvering and calculated judgments being executed 2 doors away. Their sense of security, ship-like in the air, belied the complex aerial dialogue occurring miles above the ground. The descent, facilitated by the dampened Dutch roll and sharp pilot response, was engineered to allow progressive easing of the aircraft's stress. At each tier of altitude diminished, the cockpit became a hub of concentrated calculation, balancing the need for altitude loss against conscientious, safety-first approaches. The altimeter's drop in numbers underscored a pure, undiluted pursuit of equilibrium, a necessity within the operational landscape they navigated. Yet, the achievement of stability was not without its lingering doubts. The unsettling origin of the in-flight disturbance still hovered ominously in the minds of both crew and command. The missing component that had clandestinely destabilized an otherwise routine flight posed a hectic challenge to maintain control amidst modern avionics' inherent unpredictability. No evidence on the control panel could offer reassurance that the mechanical issue would remain dormant or isolated. Thus, every decision was imbued with a heightened sense of caution. In contacting the airline's operations team and additional regulatory bodies, Pichet and de Jager synthesized feedback from a multitude of sources. This informational relay expanded their arsenal, but ultimately, the tactical decision of Nexus remained firmly on their shoulders in the trepidatious skies. Simultaneously, they endeavored to retain an alternative, redundant safety net, recognizing the contingency they lay as best practice within aerial procedures. The specter of risk had not entirely evaporated, but prudent, systematic, and skillful control by the piloting team meant that Air Transat Flight 961 now had a poised trajectory to either resume its planned route or consider safe port alternatives. But as the descent unfolded with practiced care, fresh questions emerged. How deeply had this unseen mechanical anomaly pervaded the aircraft's core systems, and what next steps could safeguard the lives they steward? Emerging from this haze was the looming task of determining the integrity of the aircraft's critical flight systems and definitively charting their next course. Such deliberations echoed the eternal tension between returning immediately to their point of departure or continuing under a watchful, optimized eye towards Quebec City. Whichever path they chose, the eerie blank slate of diagnostics spoke volumes, necessitating both caution and resolve. The flight's future depended on rightly navigating this crossroads, underscored by the pilot's steely competence and unwavering command presence. Even as the troubling oscillation subsided, gaining a temporary calmness, Air Transat Flight 961's crew remained acutely aware that the mechanical anomaly still cast a long shadow. The preliminary stabilization at altitude concealed a more fundamental issue, a disruption in harmony that still threatened the plane's mechanical core. No longer battling the immediate physical symptoms of a Dutch roll, the true quandary lay in the veiled uncertainty thrumming beneath the still-functioning fuselage. Upon entering a dialogue with air traffic control and the airline's operational command, Captain Robert Pichet and his first officer, Dirk de Jager, did not receive the comforting assurances they hoped for. Instead, their long experience taught them to anticipate the unknowns lurking within complex machinery. The aircraft now flew steadily, but the absence of visible or audible cues made the whole episode alarmingly abstract. An atypical scenario not easily filed away by standard operating manuals or predictive diagnostics. Amidst the instrumental silence, a slew of questions populated the cockpit. What precisely had caused the initial bang? Could the source, a structural anomaly, or perhaps a material failure, pose further, unseen risks? The nagging incompleteness of their situation afforded zero ease, compelling the pilots toward a tentative plan forged of cautious optimism and apprehension. They contemplated their options: press on toward Quebec with added vigilance, or make a deliberate pivot back to Varadero, where a controlled inspection might illuminate the opaque fault. Intuition leaned heavily on retracing their flight path back to Cuba, the closest landing possibility where technical scrutiny could be expeditiously conducted. Furthermore, retaining an engineering team on standby was essential for swift remedial measures once landed. Their meticulous focus hinged on maintaining this delicate balance between safety protocols, regulatory requirements, and dynamic assessment, a decision that would further define their career path and broader aviation safety standards. Inside the cabin, the atmosphere bore an undercurrent of collective curiosity and unease. Passengers, acutely sensitive to the perceptible shift in altitude and altered trajectory, murmured speculatively. The flight attendants, acutely in tune with passenger dynamics, communicated reassurances, marshaling their calm to regulate potential alarm. They now served dual roles as information conduits and stabilizing architects, their flawless preparedness a testament to their commitment. Resolving to reverse their course, the flight leaders signaled their intentions to air traffic control and recognized the implications. Returning was not the ideal option, but the safer one, given the indeterminate circumstances. As they initiated the turn and diverted, a concentrated determination supplanted hesitation. This scenario demanded more than mechanical interpretation. It required an artistry of piloting that blended the uncompromising necessity of safety with the implicit trust underlying every takeoff and landing. The descent back to Varadero was calibrated with precision, each control input deliberate amid the societal weight of ensuring structural integrity. As clouds intermittently occluded directional markers, Pichet and de Jager nevertheless maintained their visual and electronic orientations, locked into a pact of careful execution. Each action, mundane in isolation, played into a grander narrative of safeguarding human lives and institutional trust. The psychological toll of such uncertainty on all aboard was not underestimated. Though no longer gripped by overt pathos, the specter of mechanical unreliability blanketed everyone with its subtle yet tangible impact. For the flight crew, this realization manifested as an increased burden of judgment, one that history repeatedly emphasizes but never trivializes. Yet, as the Cuban coastline blurred into view, the impending landing presented its own set of nuanced challenges. While the pilots committed themselves to the landfall logistics, one formidable concern remained. How would the aircraft handle the runway strip, given its latent inconsistency? As the remaining miles lessened, this question lingered, setting the stage for the approaching climax, underscored by the still-to-be-discovered awkward truth hiding below the empennage. As Air Transat Flight 961 closed in on Varadero, the Cuban landscape offering a familiar yet ever-precious sanctuary, the crew focused intensely on executing a safe landing. Captain Robert Pichet and First Officer Dirk de Jager, whose professional mettle had already been tested under duress, now prepared for perhaps their most consequential maneuver of this voyage. Despite the relief of returning to a known base where immediate technical assistance awaited, the latent uncertainty shadowing the aircraft's stability cast a vigilant tension over the cockpit. As they initiated their approach, the aircraft descended smoothly through subtropical cloud swathes, the sight of the emerald terrain beneath providing a distinct visual relief juxtaposed against the invisible strain atop the plane's structure. Yet, as with any drama reaching its zenith, there was an unpredictably tense soundtrack that could not be dismissed, the quiet hum of systems obscuring what the crew feared could be a critical failing. The landing gear deployed without a hitch, a small yet psychologically significant victory given the day's string of abnormalities. However, just when conventional wisdom suggested that the skillful navigation of risks had reached its near-chronological end, the aircraft exhibited unfamiliar behavior. As Pichet attempted to engage the rudder controls, a standard procedure to align the plane seamlessly with the runway, it became alarmingly evident that the rudder was unresponsive. This was not merely mechanical reticence. It was complete inertness, a flight control failure that jerked the pilots into a challenging last-minute recalibration. This new twist, pressuring the already vivid tapestry of unexpected events, reflected the complex dynamics of aviation. An uncooperative rudder demanded the crew's sharp cognition and prowess, not merely for mechanical adjustment, but to unlock a technique-driven return to Earth, surmounting yet another unforeseen variable. Here, a fusion of ingenuity and calm precision was essential, drawing from Pichet's extensive experience navigating previous airborne emergencies. In the cabin, the air had thickened with an invisible cloak of awareness. Few passengers could discern the procedural intricacies playing out beyond the cockpit door, yet instinctively, they sensed an implicit stress via subtle behavioral shifts. The flight crew's quickened pace, the somber murmur over the intercom, and the imperceptible yet fascinating serenity maintained by the flying staff. Although inevitability courted hazard, the combined effort inside the cockpit became a case study of composure in the shadow of uncertainty. Using asymmetric engine thrust, Pichet and de Jager engineered a landing path that compensated for the absence of key directional commands, executing a configuration honed in simulators but rarely needed in reality. The aircraft, despite lacking a functioning rudder, seemed to heed their guidance, if only barely, as it gracefully yet assertively touched down upon the runway. The defiance of threat supplied another moment of collective exhalation as cabin occupants felt the solid certainty of unmoving ground, a tactile comfort against a day's cavalcade of challenges. And yet in aviation, as in all manner of intricate pursuits, resolution inevitably begets revelations. Upon taxiing towards the designated gate, the importance of securing technical inspection could not be overstated. When the engines finally silenced and disembarkation procedures commenced, an unexpected discovery transformed conjectures into startling reality. Mechanics, tasked with a routine task, now laced with intrigue, found that the aircraft's entire rudder had somehow detached in flight. A disconcerting truth, petrified in fragments, at odds with the plane's safely concluded mission. The unforeseen rudder absence not only explained the landing woes, but also announced their presence with a thunderous fervor, proving that it was both the catalyst and silent witness to the saga on board Flight 961. In the wake of this discovery, investigations commenced, sparking discussions within economic, mechanical, and regulatory spheres. The complexity of what lay uncovered posed deeper questions about design, maintenance, and possible oversights. The necessary juxtaposition of immediate relief and enduring inquiry loomed large ahead, waiting to unravel the complex equation of human skill against machine limits. In its wake, a broader dialogue ensued on aviation safety and preparedness, reaching into every cockpit and control room facsimile across the skies. The uneventful landing of Air Transat Flight 961, though dramatic in execution, culminated in a moment of deceptive calm as passengers and crew safely disembarked. Behind the veil of relief, however, unfolded a startling and perplexing climax. The revelation that the aircraft's rudder, an essential control surface, had mysteriously vanished in flight. The implications of this discovery were vast, touching on issues of safety, engineering, and regulation, and sparking immediate concern across the aviation industry. Once the aircraft was safely taxiing to a halt and passengers began the process of disembarking, the ground crew swiftly moved in to conduct an inspection, prepared to grapple with the unknowns intimated by the pilots. It was within the careful scrutiny of this post-landing inspection that the shocking absence was detected. The rudder, designed to guide the aircraft's directional stability, was gone. Disbelief turned to a profound realization that the mere act of having landed at all, let alone safely, was itself an extraordinary feat. The rudder's absence was not just a mechanical mystery, it was an existential challenge to the trust customers and crew place in technological efficiencies. Investigators, maintenance personnel, and engineers huddled, assessing a scenario that seemed implausibly grim and yet eerily real. The immediate questions were dire, yet mandatory. How did the rudder become detached? At what exact point did it disengage? And most critically, were there overlooked factors or maintenance errors contributing to this apparent structural failure. Across industry channels, the loss of the rudder triggered a flurry of alerts and notifications, protocol dictating the grounding of similar models until a thorough investigation yielded answers. Aviation safety analysts delved into flight logs, scrutinizing every recorded maintenance activity, every piece of functional history that the aircraft had accumulated and thus documented. Meanwhile, the industry watched with bated breath, acknowledging that any conclusions drawn could dictate new standards and recalibrate current safety matrices. The ripple effect of the rudder's disappearance extended beyond immediate mechanical concerns. It rekindled broader conversations about structural integrity and the need for heightened real-time diagnostic tools capable of identifying such vulnerabilities before escalation. Additionally, there were discussions on pilot training programs to include scenarios that tested a pilot's response to extreme mechanical failures without reliance on specific alerts or codes, a re-emphasis on skilled decision-making as witnessed by Piche and de Jager. Within days, investigative teams from Canada and Cuba, joined by representatives from Airbus pooled resources, initiating a detailed examination of the wreckage region. The waters below the plane's recent path became the focal point of search and retrieval operations, each finding pivotal to unraveling the sequence of the initial unknown explosion and subsequent rudder loss. Findings emerged piecemeal, painting a progressively clearer picture. Early analysis suggested material fatigue, exacerbated by previous stresses, might have played a role, combined possibly with environmental factors encountered during earlier flights. Yet, as parts were retrieved from the ocean floor, new revelations perched inconveniently alongside technical blind spots, urging recalibration of existing models of corrosion, design longevity, and preventive maintenance measures. This shocking revelation of the absent rudder underscored the intricate tapestry within which aviation operations carry out their mandate: to transition human life unharmed through the skies with unwavering precision and care. As committees deliberated, technical advisors drafted amendments to safety protocols, and communication lines flexed under scrutiny, one prominent emphasis persisted: the quest for improvements was endless. The urgency reflected in real-time workshops, increased simulations, and technical symposiums convened in wake of the incident showed a unified industry keen on learning, adapting, and preemptively safeguarding against similar future travails. The rudder loss was no longer merely a structural flaw, it became a clarion call for systemic review, where every sector player recognized their role in sustaining safety as an ongoing collective priority, a poignant reminder of human resilience against the unpredictable caprices of flying machines. As these conversations evolved with increasing depth and clarity, they not only reframed Air Transat Flight 961's ordeal as a pivotal case study, but laid the groundwork for proactive adaptations, inspired by the lessons learned and the inherent vulnerability exposed by the skies. This challenge now poised the field to deliberate on how best to implement these insights effectively. In the aftermath of the Air Transat Flight 961 incident, the aviation industry found itself at a pivotal crossroad where lessons learned required translating into tangible change. Safety protocols and emergency responses underwent intense scrutiny and reevaluation. This unusual yet becomingly galvanizing event triggered widespread consultation among experts, regulators, and stakeholders, committed to reproducing the day's bravery and improvisation into systemic resilience. With the immediate emergency resolved without loss of life, the rudder loss incident cast a sobering light on the complexities underpinning safe air travel. Regulators probed into every facet, from manufacturing processes to maintenance checks and crew training programs. The emphasis shifted toward dissecting this near calamity for threads of insight that could bolster the industry's approach to both preventing and responding to similar crises in the future. One of the first actions was the swift grounding of potentially affected aircraft, a preventive measure ensuring that similar vulnerabilities were not overlooked in other fleets. Inspection teams operated under accelerated schedules, detailing intricacies down to rivets and paint layers in search of initial failure catalysts. Concurrently, technical committees comprising engineers and safety experts examined the implications for airworthiness standards, while deliberating changes to certification processes for aircraft components, especially critical control surfaces like the rudder. Meanwhile, the flight's successful outcome, against a backdrop of uncertainty and mechanical failure, highlighted the indispensable value of crew training. As in the case of Captain Robert Pichet and First Officer Dirk de Jager, reinforced training programs began emphasizing the importance of situational awareness, crisis management, and manual piloting skills. Training simulators expanded scenarios to include non-predictable events where cockpit instruments might not align with physical realities, ensuring pilots practiced responses to situations beyond standard textbooks or automatic alerts. Safety protocols, deeply embedded in aviation procedures, were tested and validated through cross-examinations, spawning potential amendments. Emergency response doctrines experienced extensive evaluations to incorporate feedback from Flight 961's sequence of actions, with risks accentuated by prevalent silent dangers not flagged by automated systems. Collective wisdom advocated that reliance on technology should be buttressed by the intuitive acumen of human operators, solidifying a hybrid safety net bolstered by both digital and analog safeguards. International air travel authorities convened summits, leveraging the Flight 961 investigation as a nucleus around which global safety imperatives could orbit. These discussions projected a vision for proactive, rather than reactive, safety management. Lessons from the rudder disappearance suggested that a culture of transparent communication and collaborative problem-solving among manufacturers, airlines, and governments was vital for sustaining an industrious front against failures. Public trust, a cornerstone of aviation's social contract, also emerged as a critical area for reinforcement. Transparent communication strategies were essential, addressing fears and misconceptions with earnest disclosures and updates. This fortified trust was not just in the mechanics of flight, but in the human capacity to address the unpredictable variables introduced by technology and nature alike. Yet, perhaps the most profound takeaway from Flight 961 was the urgent need to redefine maintenance and inspection paradigms, prompting a focus on predictive analytics that could foresee anomalies before issues escalated to critical stages. Investments in data-driven diagnostic tools promised to meld historical data with real-time makeshift prognostics to enhance failure detection. As these systemic alterations took shape, further discourse framed recommendations for long-term structural reforms designed for resilience. While the rudder's loss had sparked a flurry of reactive measures, it was the foresight galvanized by this experience that aimed to cement an enduring shift in safety culture, maintaining the momentum toward unwavering safety improvements. Now, the industry faced the broader question of integrating these safety enhancements into a coherent global strategy. Could the momentum catalyzed by this incident sustain a stable trajectory towards innovation in flight safety? The path forward embraced this dialogue, encapsulating the aviation world's relentless pursuit of turning adversity into advancement and vulnerability into vigilance.